Hello, and welcome to Nodes 2020. My name is Michael Porter, Neo4J Ninja and founder at Muddy Boots Code. As a Neo4J Ninja, my fellow ninjas and myself work on the Neo4J community forums, helping Neo4J users get the most out of their Neo4J experience. At Muddy Boots Code, we use Neo4J and the Grant Stack to help oil and gas professionals deal with tricky data problems. Today, our talk is Quarkus on Neo4J, real world experience in live coding with Sebastian Daschner. Sebastian Daschner is a Java developer advocate at IBM, a consultant, author, and trainer. He's the author of the book Architecting Modern Java EE Application. Sebastian participates in open source standardization procedures such as the JCP or the Eclipse Foundation, helping form the future standards of enterprise Java in collaborations on various open source projects. For his contributions in the Java community and ecosystem, he was recognized as a Java champion, Oracle Developer Champion, and Java 1 Rockstar. Besides Java, Sebastian is a heavy user of cloud-native technologies and anything related to enterprise software. He evangelizes computer science practices on his blog at sebastiandraschner.com, his newsletter, and on Twitter at DreschnerS. Sebastian kickstarted the JOnson and JSpirit conferences that connect Java developers throughout the globe. When not working with technology, he also loves to travel the world. And now, welcome Sebastian.
Hi there, my name is Sebastian, and in this session I want to talk about Quarkus on Neo4j, how to write Quarkus enterprise applications that use a Neo4j graph database. So you probably have heard of this Quarkus technology that is now quite hyped in the Java ecosystem, which is a modern way of doing cloud-native application development on Java. And in this session, I want to talk about some real-world experiences and, of course, live coding, how to do a Quarkus application that uses a Neo4j graph database by using features such as Neo4j OGM with the declarative graph mapping model. My name is Sebastian. I work for this company called IBM, and I do a lot of things with enterprise Java in the broadest sense. I have some Java titles involved there, and I usually speak at many conferences and do some development outreach and teaching knowledge and supporting in projects. And with this, I want to share some experiences, that I gathered by using Quarkus with Neo4j, and especially what Java developers, what Quarkus or enterprise Java developers have to take into consideration when using Neo4j or a graph database in general. We developers probably have a lot of experience with using enterprise applications that use a relational database. And now I specifically want to show you, how to use a graph database, especially from your enterprise application. What I'm going to do is I have a playground application, so I will do a lot of live coding here. And this application is a somewhat coffee shop example. So I have a Java application that is actually Quarkus application. So I'm using Quarkus in this version on Java 14. And the application does a lot with coffee. So I have some coffee examples. We're going to talk a lot about tasty coffee in this session, and we want to see how to model things in a graph, and specifically how to access that graph and how to query and update it. Now, what I want to show you first is how to run a Neo4j instance. So I have a very basic shell script that just runs a graph database in a Docker container. So this is what I'm doing locally already. And then in this case, I want to add some examples. So I have some Cypher scripts, that is the equivalent of a SQL script in the relational world. And I have a Docker container running there already. So now I want to add some Cypher scripts here for specific data that I want to add. So I have some scripts that are migration scripts actually. I will show you what all that does later, but that we can have a look. First of all, I'm going to add some scripts, and then we can examine how this example data and the structure looks like in the browser. Because one of the killer features, what I really like about the Neo4j database, is this browser that runs under a localhost 7474 if you start it locally, and this Neo4j browser can just examine what is in our graph. And now let me just change the layout a little bit so you see this. What we have here, this is already our graph. This is actually all of the data that we have in our model. I'll just now quickly change this a little bit so we see a better, well, representation of what we have. So originally we have some coffee beans. This is the basically the starting point of what we do in our application. We want to have some beans here. So if you go to a nicer coffee shop and order some coffee, you in a better shop can actually select which beans you would like to have, right? Because they have different tastes, they may be roasted differently, and so on and so forth. And what we have here, this is just a coffee bean, so this is a sort of coffee if you want. And if we double click, we can expand our model here with the relations. So what that is, this is first of all just a node. This is an entity in the graph, and the entity has the relations. In our case, our coffee bean has some specific properties. In our case, that's only a name. It's called this way, Elgato Loco, and roast. So it is a light roast. We could have a medium roast, a dark roast, it depends. And it is from a country or an origin, in this case, Colombia. And it tastes like something. So let me just quickly change the layout here so we have a name. Coffee has some specific taste. There is a coffee taste wheel available that describes different tastes, such as fruity taste, floral taste, nutty taste, caramel taste. And it tastes like, this coffee bean tastes fruity and floral. So why do we have this in a relation here? Because, well, later on for queries, this might actually be very helpful. So imagine in a relational world, you would have this coffee bean entity and then property, such as in a mapping table, in a different table, it tastes like this taste and it tastes like another taste. In this case, it would be a property that would also be a straightforward solution. But later on, we will see that it's not this helpful. Okay, this property has some percentage. So we can say, well, it tastes like both floral and fruity tastes, but only to a specific percentage. So we say, well, 30% floral and 70% fruity. So this relation, this arrow, has a percentage, a weight in our case. So this is like a directed graph. And that is already the basic. Now, in our application, what we want to do is that we want to access this, and, well, we want to access all the data here. So, for example, please give me all coffee beans and show me what properties they have. Or, of course, you can already imagine, well, I'm actually interested in fruity coffee, right? So I like this taste, so please give me all beans that taste like this. So if I double click on that, then I see, well, actually, this is the case for these two beans, right? So these two beans I probably should order if I would like to have some fruity taste. And then we see a little bit more in our graph model later on. Now, how this works in a Quarkus application. Quarkus actually has some basic, for now, as time of recording this, some basic support of Neo, Quarkus Neo4J, but which is only, in quotes, quote unquote, the driver. So Quarkus itself doesn't have the Quarkus OGM support natively yet. So we have to do this manually by basically adding some dependencies. I'm adding the dependencies, and you can check out the code later on if you like, for all of these Neo4j OGM dependencies. OGM is very similar to what ORM is for relational databases. We have the graph mapping model, so we can declaratively map something here. If I show you how CipherScript looks like, maybe you're a Java developer, you haven't seen this yet, if you haven't played around with Neo, then it looks somewhat like follows. This is how I created my data in the graph. And well, of course, I could say, in order to access something, I could use these match and then return statements in order to query my graph. So I could actually do this and write some scripts here and then access this directly. But what I want to do instead, I want to use an OGM extension so I can have a declarative mapping in my application. Why? Because it's much more convenient to write this. So if I now show you the entity class of the coffee bean, so this is now my domain model within my application, you will see, okay, we have annotations here that look somewhat, well, similar. I would say if you're used to the enterprise world, we have an @ID. This is not JPA. It actually looks very similar, but this is Neo4J OGM. And we can map a relationship and some properties and so on and so forth. So if you have a look at the documentation, you see all of the meaning of this. But I would say as a regular enterprise developer, it looks somewhat expected. It looks somewhat familiar if you want to use this declarative mapping. So this is very nice that we can actually make use of this. Now, how to put all of these pieces together. With Neo4j extension of Quarkus, we can actually configure, well, first of all, what we need to do, of course, our database URI and username password. I can make use of this property of these profiles, for example, for development mode. Well, I will know that this actually runs localhost rather than in a specific name. We will come to that later on. So now, if I actually run this locally, it will work with my example. I will show this in a second. And then, well, how to connect to the database. In my case, I actually have to use, well, I have to produce some what is called sessions directly. And this is now the integration with Quarkus here, since there is no official support similar to a JPA mapping such as Panache yet with Neo4j. We have to do a little bit of manual work here. So I use some CDI features, CDI producer methods, to produce what is called a session factory. A session factory, as the name suggests, will produce a session later on, and a Neo4j session, an OGM session, helps us to access our graph. And we, of course, dispose this later on. So we have a possibility to inject our session factory later on in our CDI beans. And this is what we're doing here. So if I would start in the beginning to say, we have a JAX-RS resource here. This is the boundary of our application. I will show this in a second how it works when we run it. And we have just one entry point for our business use cases, this coffee beans, plural, class, which, well, accesses our data. Get coffee beans with a specific flavor, whatever that means, and so on and so forth. And what we do, we inject a session factory. And then we open up a session. Let's have a look at this method first. We open up a session here and we use that session to just return all the coffee. Okay, great. What you see here, this is already very convenient. We don't have to specify for this very method a query even. We can use a very similar typed way like we could do with JPA in order to access our data to say, please load all the coffee beans, sort them if you want, load them with a specific depth. This is the 1 here. So, if you think of the graph, like how many related nodes do you want to load also? In this case, only 1. So the coffee bean and then later the flavor. This is how this is mapped here. We have a coffee bean. Now, if you remember, a coffee bean has an origin. It is from some country or multiple ones actually. And it has some flavor profiles. What is a flavor profile? Let's have a look into this. A flavor profile is basically saying, well, to which percentage does my coffee bean taste like something? And the flavor, something, this is like, well, one of these coffee flavors in the coffee wheel, flavor wheel. So it might be fruity or nutty, caramel taste, floral. And this is what the flavor profile maps here. So we say, well, up to 30% it is a fruity taste, for example. And this actually maps to not a node, but the arrow in the graph. So this later on will result in this arrow that we say, well, 30% floral taste. So that is then mapped by this corresponding class. All right. So as some gotcha here that I ran into, you actually have to provide IDs for the entities and the relationship entities. This can be the generated value, then Neo takes care of that. We specify some start and some end nodes and so on and so forth. So basically, well, where does it start and where does it end, which makes sense. And now finally, let's run this. So I run Quarkus dev. Good story is that this, well, it's not really a support, but that adding the OGM dependency of Neo4J actually works with Quarkus also in the development mode. So what we can do, we can start up Quarkus in a development mode, what I'm doing here, and then I can take curl localhost 8080 and just go to my application. In this case, I use the beans resource, so we have it here, /beans, to access it. And then we see, well, this is now starting up. It's executing all of this data access functionality. And let's pre-print this. We have the data of our coffee beans. So let's have a quick look into this. What does it say? Well, we have some beans. It has a name. And it has, of course, some origins and, this flavor profile that we specified. So this is basically the data that we had in our graph, now represented as JSON. And this is what you would typically want if you then access your external API from your application. So now I just say I want to have a JSON API, I want to query my beans, and so on and so forth. So this is very similar to what we had a look in the graph browser. Awesome. Okay, so this already works. If you have had a look at the code, this is basically the first query with a very basic method. Now let's get a little bit more specific. Let's use some of the power of our graph database, because it especially shines when we say, well, we have to, or we want to run a little bit more complex queries, especially asking, well, give me that specific coffee beans, but only for a specific flavor or where it matches some situation and so on and so forth. So if we say, well, I want the coffee beans not for all of the beans, I'm not interested in that. I basically only want some flavor where, well, the flavor is, let's say, fruity, where we have some fruity flavor. And in this case, please only return the coffee beans that at least up to some degree have this flavor profile that includes fruity taste. Awesome. So now I'm only interested, I like fruity coffee actually, so I'm only interested in these beans, and this is done by that method for a specific flavor. How does this work? Let's have a look into this query. What we do here, because it's the easiest thing, we just write a cipher query. And you would say, well, actually it might be, pretty sophisticated here. But what we do in this case, we only have to, well, write this one. The other one I will explain in a second, but to say, well, match a coffee bean where we have this relationship tastes like some flavor with flavor name, well, in my case, fruit. So I'm not interested in how much it tastes like, just at least have some taste of fruity taste in my bean, and that's it. And what I do here, well, I match it again. Why? Because then otherwise I would only return this information if I say match this and then just return. No, I want to return the whole bean with all of the tastes, right? So I'm actually interested in all of the bean taste profile. Otherwise it would just, well, return the fruity part because I matched for this specific sub part of the graph. But in my case I want to have everything, so this is why it's basically a rewind match again from this very coffee bean that you just matched. Now give me all of the information, return all of the information, and then return it ordered by the name. Okay, now at first this looks probably a little bit complicated, but well, it isn't. If you think about it, so this first match basically matches the information what we want to have here. And the other thing is just, well, an additional addition of the other information that is also there. So for example, we have more is from a country, potentially. It might have more origins. It might have more tastes, not just this fruity taste. So it basically says, well, select all in this graph that is connected to my node. And the cool thing, what I like about OGM, if we add this in the return query, if we say, well, return this information also, we have to specify it here, but then we don't have to map it. So this is done by OGM, that it says, well, actually I have this relationship and this property and that relationship, so it will be added here automatically. So my result here will already be propagated and properly, so it will have this information. And then we get this information here. So that's pretty cool, I think, already with a little code. And now where it really shines is where we say we have some more advanced queries. So if we want to query, please give me some coffee beans with unexpected flavor. What does it mean? I call them special beans. So if we say, well, if you go to beans and then slash special, then it will return some special beans. What are special beans? In my business example, this means we have beans with unexpected flavors. What is an unexpected flavor here for coffee? Well, if we have a coffee bean, then coffee bean is from one or more origins, and an origin typically, such as, let's have a look into the browser, such as Colombia, we say, well, Colombia is typically, you can say that it is known to produce fruity and floral coffee. So you can actually say this if you have a specific country origin, that it typically tastes like, this or that. And now if we say what is an unexpected flavor, if we basically get a coffee bean where it is from a country for, specific flavors, but yet although it is from one specific country, the coffee also has some other flavors that we would not expect from that country, right? So that is somewhat untypical for that location. So it doesn't match the stereotype of that specific coffee country, but has something else as well. How do we do this in the graph? So in a relational database, now this is really like mind bending, and you have to have the black belt in SQL script, right? To do something like that, to say, okay, now give me the countries and then try to merge or join them by the flavor that you would get, and see, okay, where there is a mismatch or where there is an overlap. In this case, actually, it is much easier. It is only, well, first of all, these two lines, match, and then, well, match this triangle, basically, coffee bean that is related to a taste, and that is also from a country. So this triangle match where, now that is the interesting part, next line, where the country is not known for that flavor. So do a triangle match of this coffee bean country flavor where that is actually not known. And since we now have these two nodes here in this, these three nodes in this query line, we can use them where this country is not known for that flavor. Which now, if you think about it, really makes sense. This is very readable and actually very logical if you just read these two lines of code. And then say, okay, give me these nodes. And then again, it's very similar what we do before. Please match, all of the flavors. So in case you have something here as well, just return all of that information. Now also again, that OGM feature that we return everything. So that's pretty cool. And then we return this as well. So basically what we get here, if I say please run the special beans, we get this bean and that bean. Why? Let's have a look at the graph. So this was this one. Why? This bean is from Ethiopia, and Ethiopia is known for a sweet taste coffee, but that bean also tastes like a caramel taste, which is actually where Ethiopia beans are not known for, so to say. That's now just my example, but that makes this somewhat special. For this bean, it is not the case because it tastes like fruity and floral taste, and Colombia is known for both fruity and floral taste, so it is, well, not unexpected, so to say. It is the case for this bean and for that example. So this is what we mean with this unexpected flavor, just to have an example of a more sophisticated use case where you can really shine by running a Cypher script as opposed to relational data or something, where it really helps that we now have a graph database in our system. And this is how we combine it in our Quarkus application, and then we can return the data. Awesome. Okay, now if we would like to create some new coffee, this is now also interesting how to do it. So, well, bad news first, we have to manage some transactions manually because as I said, there is no full support of a transactional model within Quarkus yet, like what you use from JPA or what Spring does with the Spring modeling in Neo4J. But good news, it is not that complicated. We can make actually use of lambdas. So I typically have a method such as run in transaction, and then I can have a runnable and basically add this with a lambda expression, and then say, well, please session begin a transaction, do the typical try catch, commit and close or rollback, and so on and so forth, and then in the middle run the transaction. And in this case we say, well, create a new coffee bean if we basically provide all of that data. And in this case, create the bean here, make sure that the name doesn't already exist, and so on and so forth, add some flavor profiles and make sure that this is actually all legal. So in this case you can have you can make use of this session to query other beans that you need to, or other nodes that you need to match within your graph, and then add this here. So you can check out the code if you like, just for one example, how to do how to create something here in your application. So this is typically what you could do by using this Neo4J session type to then make use of loading a graph and then matching some data here. So this is basically a straightforward way of creating something. I can include this here as well. So I included that in my resource, and then I can create some beans. So here I just have a JSON example of saying flavor profiles and so on and so forth. All right. So let's try this out. I have something prepared here where I say curl localhost and then now just create that. So basically what you see, I hope that's somewhat readable. This is a JSON that I had there before, so we can have some test bean 1, 2, 3 from a specific country here, in this case light roast, and some flavor profiles. So now, since I want to add all of that information already, this is a somewhat more complex JSON. Let's fire this up, and it says yes, it works. And in our case, if I say, okay, now please query all of the beans here, and then, well, return, the name, for example, or just all of them, we see that there is a new bean here, test bean, from Colombia with this specific percentage. If I would create something, illegal, then I, just in my case, if I would do this again, that it says, well, now it gives me a stack trace because I run in the development mode, and it basically has, well, bean with name already exists. So I would typically output this in a nice readable form. Now, since Quarkus runs in the dev mode, it gives me even a stack trace with helpful information to say, okay, where is the exception? Typically in an enterprise application, I write an JAX-RS exception mapper and says, okay, bad request. It is not valid. Let's say, okay, we change this test bean 1, and then but we increase the percentage so it doesn't match to 100%. Then it's also not valid, and it says, okay, actually the percentage of the flavor profile has to match. It has to add up to 100% here. So this is also not valid, and so on and so forth. We can include this in our business use case specialization here by saying create bean and so on and so forth, but do all of this within a transaction. So that is just the integration that we need to know to use this within a Quarkus application. So again, session factory is being injected. This is very handy, and then typically that is somewhat the way to go, to just open up a session. So these sessions are very lightweight to create. The session factory is the bigger object, so we only have this once within our application, and then we can use this to interact with our graph. All right, now this is basically the what you need to know in order to get started with Quarkus. So how to integrate it, how to map my graph with either very basic queries that can be done in a totally typed way, or this is somewhat the experience that we got from running more sophisticated queries. It really makes sense to then just run the queries and try them out in the browser and run them in your scripts, and then use them as inline queries within your application, and say, okay, please execute this query, add some potential parameters such as the flavor name and so on and so forth. So this is being added here, and you can check out the documentation of OJM how this looks like. If you're modifying some data, then you would need to begin and close your own transactions. So what has been proven itself is if you just write a class similar to this, where it encapsulates the responsibility to interact with the graph, then it really makes sense to say, okay, here we have all the responsibility of doing all of this transaction handling, the session handling, and so on and so forth. And then it is, well, encapsulated here. It is abstracted, and we can use it from somewhere else, from our resource class here. For example, we have a nice business abstraction. So this is what I would do in order to integrate that, and then it's very straightforward. So I'm quite happy with the integration, how it works as of now, and how to run this Neo4J with Quarkus. All right, now we have this basic example how to run this locally. If you want to learn a little bit more about that, how to run it here, I created some example for you. You can check out the repository here on GitHub. So there is a playground. I explain how to get up and running using local Docker containers, and also how to run it in Kubernetes. So I created some videos and some explanation here how to do this in detail if you have a Kubernetes cluster. And this is what I want to do now. I want to actually show you how to run this in a more sophisticated cloud native way, where Quarkus really shines, to say how can we deploy this on a Kubernetes cluster. I have some Kubernetes clusters here. I use usually a managed cloud version. I use the managed IBM Cloud, the IKS Kubernetes service, to create some clusters. And I want to access such a cluster here. So I actually already deployed Neo4J to Kubernetes. If you want to know how to do this in more detail, I created some resources. There are actually helpful Helm charts out there, how to do a cluster, a Neo4j cluster within a Kubernetes cluster, basically multiple Neo4j nodes that run here, how to do this within a stateful and sophisticated way using persistent volumes and things like that. Or for more test purposes, how to do a single core cluster, basically, one core, similar to what I just had locally by having one container running there. And I want to show you how to do this now. Or basically, I want to show you how to deploy the application. I already have this in a standalone single way deployed on my Kubernetes cluster. So if I say kubectl, get pods, it returns this very single cluster. So this is basically one instance, one pod running that is included in a so-called graph db neo4j service. So this is my Neo4j running in the cloud, running within my cluster. This is only a regular Kubernetes service, so it can be accessed within the cluster, and this is what I will do within my application. All right, I now just start this up by deploying my YAML. What do I do here in order to deploy this example, my application? So this is now my Quarkus application. Well, first of all, I have to bundle it up as a Docker image. This is what I do here. You can check that out. That's all part of the example. I use OpenJDK in an OpenJ9 flavor to just run this as a Docker image. I, of course, add my Quarkus application, and there we go. That's it. And then I say I want to deploy that image. That is very straightforward. That's just hello world Kubernetes, right? But now it is interesting, how do I configure my graph? Well, first of all, I want to configure that URI. And what I can do in Quarkus, I can override these properties by providing environment variables, by uppercasing and replacing the dot with an underscore to say, okay, that should be the following URI. And more importantly, how to replace the password, like that is just a test access, but to say, okay, that's a username and password. And of course, you don't want to check that into version control. So you want to inject it from a secret, of course, from a Kubernetes secret. And we have such a secret here by providing the Helm chart. So I can then say I want to override that property within my running application from this secret reference. And then we can inject this into our application. Awesome. So that means we then have one replica of our application that of course has a service coffee shop. And since, well, just for my example, I actually run an Istio example. So here I will just deploy some Istio gateway, virtual service, and destination rules. So that is just the, somewhat hello world example of running this in a Kubernetes/Istio cluster within my IBM Cloud. And, well, how do I do this? I basically say, go to my repository and then kube control apply. I'm pretty sure you have done this before, to apply my YAML file, and then it will deploy, well, the destination rule, virtual service, gateway, deployment service, and hopefully I get a running pod here. Okay, great. Now the pod is running and soon it will be ready. And then once it is ready, I can actually use, well, my IP address of my cluster and say, well, please give me the coffee shop beans. So in this case, I already added this example data to my database that runs in the cloud. So now it actually returns the cloud coffee, if you want, the production workload of my Neo4j instance that runs within my Kubernetes example. So this is basically how you integrate the Kubernetes example with the YAML resources here for Kubernetes with my Quarkus application. Interesting thing here is, how do I ideally configure my database? And I think the most easiest and straightforward way, not to create multiple images like different configuration flavors, is to say, please override the configuration for my database URI and username, password, and whatever you have. You can very simply override these properties and providing them from a Kubernetes config map, or in this case, a secret. So this makes sense, I think, and then you can store this within my Kubernetes instance. Where the data is stored is basically, well, in persistent volumes. So we have a persistent volume claim that has been created by this Helm chart. You can check out the videos how to get that. Good news is, if you use a managed cloud, then this will be created for you. The persistent volume will be created for you. You create a persistent volume claim that is included in the Helm chart, and then you wait a minute, and then it is there, and then you have this persistent volume that actually stores your data. Now, what I also found from in general running production workload, you also of course have to have a more sophisticated way how your data is being managed, and especially how your databases are treated. So can you run a database within a Kubernetes cluster? Yes, of course, if you manage it properly in the same way like you would manage any production database, right? So I also created some resources how to, well, migrate graph schemas within Kubernetes. So basically say, well, if I have a longer running application and if I want to provide zero downtime by, well, not having my user experiencing some downtime, then as always, I have to think about data migration, especially data schema migration. So what happens if I want to refactor my database? And what you should check out there is, if you check out this material, there's a nice tool for Neo4j migrations, and there is an APOC library which helps a lot with refactoring graph structures, so how your graph looks like. So for example, if you say, well, you want to refactor all of the nodes because now you found out that the relationships are better modeled in a different way, and so on and so forth, and then you can include this into migration scripts and running these migrations as part of your Kubernetes deployment. So this is then basically explained here how you do this in usually init containers, things like that, where then you have a migration image where you can migrate your schema version to a specific target desired version, similar to these specific scripts that I applied in the very beginning. But this is then done automatically, and that is the point that you want to have. You want to have a sophisticated process with quality being built in how you run production workload. So this is how you do migrations. Of course, you have to think about backups as well. How to do these backups, I explained this in another resource here. What is very important is to think about these persistent volumes that I just showed. especially if you use a managed version, then they are created for you. And well, that's not it. You of course have to draw some backup, and also you should test your backup. So here I explain how to do a backup with some Kubernetes job that basically connects to this, gets the data, and then out of band in a second example, what you should do is to create another test Neo4j instance where then you try to restore that backup, try to apply it again to a new Neo4j version, and ideally also then deploy your Quarkus application that then accesses this and sees whether it still worked, whether your backup works actually, because that's very important to test. And ideally you also have an automated restore process in case things go wrong. So this is somewhat explained here. In general, as a takeaway, you just really have to think about how do I run my production workload in production, and that's the same also in Kubernetes. It actually doesn't change here when you run your enterprise Java application there. So this is something that you can check out. Especially the integration with Quarkus, I think is really cool here. How to do this with Kubernetes. So this is where Quarkus shines. You can check out these init migration containers and all of this. One more thing I want to show you just as a takeaway, or as some gotcha that I ran into, is some merge parts of the basically merge statements within your queries, because this is something that I ran into. The documentation in general is very helpful, so you might check that out. The docs in general for the Cypher for Neo4j, and there's also an OJM with the Java documentation. So how all of that works with all of the annotations that we had, so what I showed you in the example, and so on and so forth. Specifically with the merge, you have to be sure like what structures to merge on. Otherwise, that happened for me a bunch of times. You create things where you actually didn't want to create half-existing structures that are half-existing already, and you just have to understand how these merge statements actually work. So this is really helpful here, and in general it just makes sense if you're not that familiar yet with the Cypher query language, that you just get used to all of the statements and how it works. And then you will see, so this has been my experience, that at first it looks a little bit weird, especially with all of these arrows and things like that. But once you get used to it, you can write really concise and beautiful code that is very expressive. So to say, especially when querying, to say what do I want to select, select where this is the case and where this relation exists. So in general, if you model a graph database, you really want to think of all of the relations. So the power of the graph database lies within the relations and not necessarily the properties of a node. So sometimes, as some takeaway, you might find yourself modeling a relation where you would not initially, consider doing so, where if you come from a relational world, it wouldn't initially make sense. For example, if you do some task management where a task is attached to a date, then we were modeling some, date nodes, where a node of the graph actually represents a date or a timestamp within the time, if then this is being used for accessing and querying the data, because then it's really efficient to say, well, please give me all of the tasks or coffee beans or orders within a specific date, and you go via the route of that node that you actually created specifically just for querying. So you somewhat can optimize your how your data is represented, and really and have efficient querying traversal paths if you want. So this is really cool about graph databases, and what I showed you is how to integrate this into a Quarkus application, specifically with a recent Quarkus version and the OJM model of Neo4j. So let's hope that in a future version that will be integrated into Quarkus itself. But as you saw, and this was the main motivation of this talk, you can also already integrate it quite efficiently by using Quarkus and CDI features to create these types in a somewhat minimal way with little impact on your code, and then accessing the graph that you have either by writing Cypher scripts yourself, or by using the type version, or of course by using transactions in order to interact with the graph, and then use this example in that way. So I hope this was helpful. Thanks a lot for your attention. You, of course, can check out all of the resources. So I linked some of the blog examples here. If you follow the first link, then you can get the whole source code available, just everything what I did here. You can try it out with Quarkus yourself. This is what I would advise you to get started, just to run the Quarkus application and Neo4J within a Docker container. This is really cool and straightforward. And to be honest, it's just fun to play with the graph in the browser. So that's really cool. You can drag and drop nodes. And then this is how to get started. So again, I hope this was helpful. Thanks a lot for watching. Bye.